Hi everyone, meet my robot Barry. It's a garbage collecting robot. Barry is fully autonomous and it can be controlled via a manual mode too. It can move and avoid obstacles and speak to you and open its lid when it detects any hand movement above it. And it also monitors its own temperatures and shows by these three LEDs. And it runs by Raspberry Pi 5 and Arduino Nano 33 IoT and with voice, GUI, and real-time updates controls. Let's see what Barrick is consist of. For this project, I use a Raspberry Pi 5 4GB variant for controlling the Arduino Nano and operating the voice commands. And as we know, the Raspberry Pi 5 heats up a lot. I also installed a temperature monitoring system, which is these three LEDs. The first LED, as you can see, is the green one. It turns on when the temperature is under 50 degrees Celsius, and when the temperature rises above the 50 degrees Celsius, the middle one, the yellow LED turns on. So it tells us that the temperature is warm and Raspberry Pi 5 can handle the all the tasks well. And when the temperature rises above the 65 degrees Celsius, this red LED turns on and guide us that we need to shut down and cool down the Pi. As we all know that at 75 degrees Celsius, when Pi reaches 75 degrees Celsius, it's throttling down and starts decreasing its performance. And all the positive terminal are connected to GPIO pins and the negative to the GNDs. And here I installed and also one more LED. The purpose of this LED is to tell us when the remote control is on, when we are controlling the our robot via manual mode. So it's for that. And I used 4 resistor for all the 4 LEDs, the 220 ohms, so it can get a safe current. And to power the Raspberry Pi 5, I use a power bank of 10,000 mAh. It can power 5 volts. So here's a, as you can see, here's a box which is our bin. To open the lid, I use a MG90 as servo motor. It's different from SG90. The key difference is that this motor can rotate up to 360 degrees, and the SG90 SG90 only can rotate up to 180 degrees, and it's also more torquey. And for the wiring, the main wire of MG90S is connected to the GPIO pin, and its power the power positive wire is connected to the 5-volt pin, and it's black to GND. And here I use an ultrasonic sensor. This is HRSC04. And for the wiring of HCSR04, I defined two GPIO pins for the trigger and echo. And for the GND, I connected obviously to GND. And for the VCC, I connected to the 5-volt power supply pin. And here I use a mini Bluetooth speaker which is connected to the Raspberry Pi 5 via pairing. The robot is made up of two levels. The sheet is made from laser cut acrylic sheet. The first level, the base one, is this, and the second level is this, which holds the bin and the Raspberry Pi 5. And here the base level holds all the four motors and the battery and all the sensors plus the motor driver and the nano. I use four 6-volt DC motors, two on each side of the robot base. The front and rear motors on each side are connected together, which helps in distributing the movement evenly and giving enough torque to move the whole body. And here comes the powerhouse of our base. It is a 12 volt 2500 mAh lithium ion battery. It is connected to our motor driver via 12 volt pin and further powers our whole system via 5 volt pin. I used the L2989 motor driver to control all the 4 DC motors in my robot because the Arduino Nano 30 IoT cannot supply enough current to drive them directly. So coming to our motor driver, it consists of 4 out pins to powering the motors. In the left, as we can see, there are out 1 and out 2. The positive of the left side motors, the front and rear, are connected to the out 1, and the negative of the left, front and rear are connected to the out 2, and same for the right. The positive of the front and rear are connected to the out 3, and negative of the front and rear connected to the out 4. So it and our motor drivers power the RDC motors in pairs. If it powers out 1 and out 2, the front and rear wheel of left side will move, and if it powers the out 3 and out 4, the right side of our front and rear will move. So it helps in the moving of the robot in the left or right direction. When it wants to move left, its right and right side front and rear will move, so it will rotate to the left side. And here, as we can see, there are 6 pins on the our motor driver, and these like the pin from ENA to IN2 controls our left side, and pins from INA3 and INB controls our right side. They are all are assigned to the Arduino Nano pins, but the main 2 pins are ENA and ENB. They are assigned to the PWM pins on Arduino Nano for controlling the speed of the DC motors. And like when Arduino gives signal to IN1, our left side front and rear will move frontwards, and when Arduino gives signal to IN2, our left side front and rear will move backwards, and same for the right. Like when Arduino gives signal to IN3, our real right side front and rear will move backwards. I guess it's move, yeah, it move backwards. And when give signal to IN4, our right side front and rear will move frontwards. And as I told you, our ENB and ENA are for the speed controlling purpose, which are connected to our PWM pins on our Arduino Nano. And for sensing the obstacles, I use for ultrasonic sensor the HCSR041, the 3 in the front and 1 in the rear. The front center detects obstacles straight ahead, and front left and front right detects obstacle at slight angles, helping the robot choose safe paths. And the ultrasonic sensor at the rear is used for reversing and avoiding back collisions. These ultrasonics work by sending ultrasonic waves and measuring how long it takes for the echo to return, and calculates the distance in centimeters. And for the brain of our base, the Arduino Nano 33 IoT is the main microcontroller that handles all low-level hardware control. It reads data from ultrasonic sensors, controls the motor driver, and manages the LED indicators. It's also capable of UART communication with the Raspberry Pi, so that both can exchange data and commands. As you can see, these 3 pins, they are for the UART communication. 2 of these are RX and TX, and the black one is the ground one. I also installed 2 switches. I'm sorry, it's placed upside down. The first switch is this. It's the main power switch that turns the entire robot on and off. It is connected between the battery's positive wire and the L298N motor driver. And the second switch is this. Its main purpose is to keeps only the Arduino Nano powered for programming or uploading code without activating the motors. It is very useful during development or updates. Its one pin positive is defined to the one of the Arduino pins, and the negative obviously it's connected to the negative of the system. There are 2 LEDs in the front which provide us visual feedback. The white LED, it's light up when the path is clear, and the red LED turns on when it detects any obstacle in the front or even in the rear. Each LED is connected through a 220 ohms resistor. And coming to the wiring part, all 4 ultrasonic sensors, echoes and trigger pin are defined on our Arduino Nano 33 IoT D or A pins. And coming to the power supply, are all the 4 ultrasonic sensors VCC, and the 2 LEDs positives are connected to one wire, and that goes to the RL2989 a positive 5 volt power supply, and that 5 volt power supply is also powering our Arduino Nano. And then coming to our ground negative, all the four ultrasonic sensors ground and the two LEDs ground are connected to one wire, and which is going to the RL2989 motor drivers negative. And that negative also connecting to is also connected to our Arduino Nano, as it is very important for all the sensors plus our microcontroller plus our motor driver to connect via ground for the clear communication, so that our project can run smoothly. And as for the wiring purpose, all the ultrasonic sensors, echoes and trigger are defined to the Arduino Nano's D or A pins, and I joined all the positive of the ultrasonic sensors to the one positive, which is going to the L298N motor driver, and one of the 5 volt is connected to the 5 volt of the Arduino Nano 30 IoT, and all the negatives of the ultrasonic sensor are connected to the ground of the Arduino Nano 33 IoT and the ground of the L2989 motor driver, as it is very important for the ground to be connected for the robot to run. This is a smart garbage robot Barry. On startup, it takes 10 seconds to boot with a cool LED blink setup, and it also gives me some time to prepare my setup. Once ready, it patrols forward with the blue LED turn on. If an obstacle appears, the blue LED turn off and the red turns on, and it changes the path. And it also warns the user by saying obstacle detected. Wave your hand above it and it greets you. Open the lid with the servo and it waits for almost 8 seconds. Then it says goodbye and resumes. The robot constantly monitors temperature. Green for normal when the temperature is under 50 degrees Celsius. Yellow for warm when the temperature is between 50 to 65 degrees Celsius. Red for hot when the temperature rises above 65 degrees Celsius. With voice alerts in all modes. It even spins 360 degree on command. Fully autonomous and safe and interactive robot. Let me turn it on so I can show you. uh, Here's the switch. The second one is also on. Let me run the code. So it's my code.
Autonomous mode. See you next time. Take care. Okay. Ready to recycle. It was nice to meet you. Hello, sir. My name is Barry. Do you have any garbage today? Thank you. Have a wonderful day. Hello, sir. My name is Barry. Do you have any garbage today? To meet you. Hello, sir. My name is Barry. Do you have any garbage today? It was nice to meet you. Hello, sir. My name is Barry. Do you have any garbage today? Thank you. Hello, sir. My name is Barry. Do you have any garbage today? See you next time. Take care. Okay. Ready to recycle.
Show you the manual mode of the this robot. It also speaks when we switch in the modes. It's by default it is autonomous. Now it's
Manual
manual.
mode.
Let's reverse it. Let's make it forward, left. Now it will move right. There's a default in the front wheel. I don't know why the motor is not working. It's okay. It also can spin 360. That's its 360 mode. And let me show how I can open its lid and close lid backward. So coming to the Arduino code, I cannot count how many times I rewrite and adjusted it, and how many times my robot got crashed into the walls. The robot would hit obstacle because sensors were too slow, turns too late, or delay 400 was too long. Spin weekly, PWM was just 130 only. Like it also gets stuck into loops, no stop bot on mode switch. So I tested different sensor threshold like 30 centimeter, 40 centimeter, or 50 centimeters, or change the duration to 200 ms, 300 ms something, and the pivot speed to from 100 to 200, or max to max it can go to 255 only, and added and adjusted the reverse distances from 10 centimeter to 20 centimeter. Every crash meant dismantling the chassis and fixing bent wires, decoding code via Pi Arduino UART. I did it at least up like almost about 15 to 20 times. So let me be real with you. This project was hard. First, I wanted the face and voice recognition. So I brought a microphone that I guess it's over 6 pins and a Pi camera. But the microphone wouldn't work at all with Pi 5. I spent almost my all night 8 hours on it. Installed Aricold and PY audio speech recognitions, and I also tried I2S bus, which was completely incompatible, and it was I searched on Google. It was known for its bugs issue in a Raspberry Pi 5. And Airy Cold minus L shows the mic, but no audio input, just static or silence. I rebooted it, changed canals, and updated firmware. Nothing worked for me. Then coming to the camera part, I plug in the cable, but nothing shows up. Turns out that Raspberry Pi 5 uses zero point 0.5 mm pitch CSI connector, but my camera cable was 1 mm pitch, completely incompatible. And at that time, that 1 mm 0.5 mm pitch converter was unavailable in my city. So I dropped my vision and voice commands and switched to hand wave ultrasonic full lead control. It was simple and 100% reliable. So now coming to the UART communication part between Pi and Arduino. To be honest, it was a really pain in my head. It almost took me one full day from morning 9 a.m. to the next day's night 2 a.m. At first thought I used a regular Arduino Nano 5 volt logic. I added a level shifter 5 volt to 3.3 volt to protect Pi's GPOs, but no data came through. Then I researched that Arduino Nano 33 IoT uses 3.3 volt logic natively. No level shifter is needed. So I switched to the 33 IoT and removed the shifter. Still nothing. Why? Because Pi 5 uses UARTO for Bluetooth by default, and serial console login was enabled. I had to run sudo resp configuration and disable its serial logic shell, enable UART on GPI 14 and 15, edit boot configuration.txt, and edit what we say dt overlay is equal to disable slash bt, and then reboot my Raspberry Pi 5. And after that I use minicom minus b 9600 minus o minus d and dev serial 0 to test. Finally data flowed both ways, but Python kept crashing on serial read. So I edit thread logs and try accept in UART listener. So now coming to the motor parts, the motor were the one of the biggest hardware issue. These cheap DC motors have almost no torque with full chassis weights. Left front motor gets stuck, gets slips or jams. Right turns are restricted because of weight. Robot jugs or stop. I tried like cleaning the gears, lubricating it, and increasing the voltage, but nothing helped me. So finally, what I did was I wrapped electrical tape around all tires to overcome the friction, and And also I tried reducing the weight of the chassis and removed some parts. And yeah, I also increased the rotation of the tires. I increased the PWM at 200. It is strong, but yeah, it's safe for it. With one chassis it moves flawlessly. I will show you the clip next to it. But with full body friction wins. If I rebuild, I will use gear motors with 100 by 1 ratio. Now coming to the Raspberry Pi Python code. This is the smart brain with voice GUI and safety. It start 4 threads at launch. The first one is URT listener. Uh, Here it is. It listen to Arduino alert like obstacle, sensor, and mode. Then comes to the second part, that is lit thread. It only activates in auto mode and detect hand waves, open lid, and play greeting, and closes after 8 seconds. Then coming to the third part, temperature monitor. It reads the CPU temperature every 5 seconds and monitors and displays the green LEDs, green LED and yellow LED and red LED. And plus it also commands voice alerts. And then coming to the fourth part, GUI. The GUI has auto manual buttons, hold to move control, hold via cursor, and spin 360. And the open close lid only activates in manual mode. So when switching to manual, it sends mode remote plus mode instant halt. Everything is event driven, modular, and safe, from hand detection to overheating protection. My Arduino setup initializes all motor pins from IN1 to IN4 and ENA and ENB. 5 ultrasonic sensors trigger and echo pairs, 2 LED, blue for clear and red for obstacles, and URT at 9600 board to talk to the Pi. In the main loop, it checks the physical switch. If on, robot activates, and it read commands. Read command, listen to Pi command like forward, spin, and lid open. And if it is in autonomous logic, it reads all 5 sensors every 50 milliseconds. If in front, if something is in front less than 40 centimeters, says obstacle detected, and stops and turns left at 3 in 300 millisecond and 200 pwm. If rear blocked during reverse, it moves forward, and in spin command, left forward and left moves forward at 200 pwm, right moves backward at 200 pwm. All motor function using differential drive, one side at full power and other stopped, for so that it can take a sharp turn to the opposite side. So Barry isn't perfect, but it works, speaks, learns, and survive. I learned real embedded system, URT debugging, real-time control, hardware limits, and persistence. If I rebuild, I will use ROS2, better motors, and camera with adapter. Thank you. Barry is ready to clean the world.